Welcome to the Explainer. Let's jump right into this. Today, we're going to demystify one of the most crucial concepts in Python, how it handles dynamic memory allocation when you're dealing with massive amounts of data. If you've ever felt a little lost trying to untangle terms like iterators and generators, you are absolutely in the right place. To make these highly technical concepts crystal clear and actually memorable, we're going to use a simple real-world analogy, a busy restaurant kitchen. By the end of this explainer, you're going to know exactly how to write faster, much more memory-efficient Python code. Here is our quick roadmap for today. We're going to cover the heavy memory trap, iterables versus iterators, the magic of next, then enter the generator, the power of yield, and finally, the ultimate showdown. All right, part 1, the heavy memory trap. So what actually happens when your Python code orders way too much data at once? Just imagine defining a massive collection. Let's say a list with millions of elements in it, and you try to load all of that into a standard variable. Well, your dynamic memory fills up pretty quick, and if that list is too big, boom, your memory is completely exhausted and your entire program crashes. This right here perfectly illustrates the difference between eager loading and lazy evaluation. Think about walking into a restaurant and ordering the entire menu at once. If the kitchen tries to cook every single dish at the exact same time, which is eager loading, they are going to run out of ingredients, counter space, and, frankly, their sanity. That's high memory consumption. But with lazy evaluation, they cook one dish, hand it to you, and calmly wait for your next order. It saves a massive amount of memory and keeps your server from crashing.
Moving right along to section 2, iterables versus iterators.
First up, we have the iterable. Simply put, an iterable is just a collection of elements that you can iterate through, kind of like your standard Python list. In our restaurant world, you can think of the iterable as the actual physical menu sitting on your table. It holds all the potential dishes, but it takes up a lot of space. Then we have the iterator. Now, this is an object created directly out of an iterable, using Python's built-in iter function. Its one and only job is to retrieve those elements one by one. So if the iterator is the menu, the iterator is your waiter. They bring you one item at a time so your table, or in this case, your computer's memory, doesn't get totally overwhelmed. So how does that waiter actually deliver the food? Let's check out section 3, the magic of next. Let's quickly trace the exact lifecycle of an iterator. First, you initialize it using iter, but to get that waiter moving, you have to use the next keyword. Every single time you call next, it dynamically fetches just one element. But what happens when you've eaten everything and the list is totally empty? Well, the kitchen closes for the night, and Python throws a StopIteration exception. Let's look a little closer at that StopIteration exception. If you're manually calling next and the iterator runs dry, Python throws an error at you. But here is a really brilliant piece of under-the-hood engineering. Your standard Python for loop actually handles this exception completely automatically. It sets up the iterator, calls next over and over for you, and then gracefully catches that exception at the very end so your code doesn't just crash.
Which brings us to section 4, enter the generator.
Our source material has a great quote for this. Generators are a faster, more compact way to create iterators using functions. If your standard iterator is the waiter, the generator is the ultimate, highly efficient head chef in our kitchen. Instead of manually writing out clunky iterable classes and custom logic, generators let you spin up an iterator incredibly fast, right inside a standard function. But how exactly does a standard function transform into a generator? That's section 5, the power of yield. Okay, this is the big aha moment. It all comes down to understanding the difference between return and yield. In a normal function, hitting a return statement means it spits out a value, instantly destroys its local variables, and completely shuts down. The chef cooks the meal, hands it over, and literally packs up and goes home for the night. But if you replace return with yield, total magic. It outputs the value, sure, but it saves all those local variables and just pauses. The chef hands out the dish, freezes in place, and waits right there at the stove for your next order. Building one of these is remarkably easy. You just write a normal Python function, but you swap out the return keyword for yield. The second you do that, Python automatically flags it and creates a generator object. And the best part? It responds perfectly to that next function we talked about earlier. Every time you call next, the function wakes up, runs until it hits yield, hands over the value, and goes right back to sleep. All right, we've got all the pieces now. Let's put them head-to-head in section 6, the ultimate showdown. If we look at this comparison table, standard iterators use the iter keyword, while generators are built using just a standard function. For getting data, iterators rely on next, while generators push data out using yield. Now, both of these are way better than eager loading for sure. But because generators create values strictly on the fly without storing an underlying collection, they are incredibly memory efficient. And here's a really fascinating technical nugget from Python's collections module. If you run a test using is subclass to check if a generator is a subclass of an iterator, it actually returns true, which means every single generator literally is an iterator. It's just a highly specialized, super compact version that saves you from writing all that manual boilerplate code. So let's quickly summarize what we've learned today. Standard lists and iterables load entirely into memory. That's your massive, heavy restaurant menu. Iterators solve this by fetching things one at a time using next. That's your helpful waiter. Generators take it a step further by creating those iterators lightning fast using the yield keyword, pausing execution and saving state. That's your highly efficient pausing chef. Bottom line, generators are your go-to for writing faster, much more compact, and amazingly memory-efficient Python code. As we wrap up this explainer, I want to leave you with a quick challenge. Take a look at your current Python projects. How many bulky, memory-hogging lists or complex for loops do you have that could be instantly optimized by simply swapping in a Python generator? The next time you're cooking up some code, remember our pausing chef, use that yield keyword, and keep your memory light.